Okay, students, we are working on Chapter 2, Lesson 3, which is dividing mixed numbers today. So go ahead and have your books open to page 72, where we will begin. And we'll go ahead and enter our learning target in to start with. Today it should say, let me get my pen ready here. I can divide mixed numbers. Oops, wrong color. All right. All right, we've got our learning target in. We'll go ahead and take a look at some vocabulary. The top of page 72, it says dividing mixed numbers. We're going to write each mixed number as an improper fraction and then divide as you would with proper fractions. So our first step is always going to take that mixed number we're going to transfer that mixed number into an improper fraction. Once we've done that, then we can divide our numbers just like we did in our last lesson. So we can do the same change, flip the fraction. I've already taught how to change a mixed number into an improper fraction, and so we'll review that today as we go through our examples, but we can go ahead and get going on those next. So, still looking at page 72, we'll take a look at our first example. Example 1 says, find 2 1/4 divided by 3/8. So we'll write it out. So we're going to change our mixed number into an improper fraction. So our mixed number is sitting right here, 2 1/4. Remember, we take our whole number, multiply by a denominator, and add the numerator. So 2 times 4 plus 1. 2 times 4 is 8. Adding 1 is 9. So this becomes 9, and we keep the denominator the same. Now we're going to take 9/4 and divide it by 3/8. To review from our last lesson, we don't actually do any division. We're going to same, change, flip the fraction. We're going to keep the 9/4 the same. We're going to change the division sign to a multiplication sign. And we're going to flip that second fraction upside down to its reciprocal. Now we can go ahead and see if there's anything we can simplify at this stage. I know that 4 can go into 4 and 8. So 4 can go into 4 one time. 4 can go into 8 two times. I know that 3 can go into 9. 3 can go into 3 one time. 3 can go into 9 three times. So now that I've simplified, I can multiply my numerators. 3 times 2, which would give me 6. And my denominators, 1 times 1, which would give me 1. 6 over 1 is the same thing as saying 6 wholes, which would be our final answer. Next, we'll take a look at example 2. The difference from example 1 to example 2 is that both numbers in the problem are mixed instead of just one. Example 2. The problem says 3 5/6 divided by 1 2/3. 3 5/6 divided by 1 2/3. So now we're going to change both mixed numbers into improper fractions before we do our division. So we're going to take our whole number times by our denominator, add our numerator. 3 times 6 is 18, and then we have plus 5, which would give us 23/6. Go ahead and keep my division sign. Whole number times denominator, add the numerator. 1 times 3 plus 2. 1 times 3 is 3. Add 2 more would be 5. So we have 5/3. So now we'll same, change, flip the fraction. Keep the 23/6. Change the sign and flip the second fraction. I know that 3 can go into 3 and 3 can also go into 6, so I can simplify those. 3 can go into 3 one time and 3 can go into 6 two times. 5 and 23 cannot be simplified, and 2 and 23 cannot be simplified. So now we're going to multiply straight across. 23 times 1 would give us 23. 2 times 5 would give us 10. Now some students would stop here. However, there are wholes that we can take out of this. So we can ask how many 10s can go into 23. And 10 can go into 23 2 whole times, because 2 times 10 is 20. And there are 3 leftovers out of 10. So we have 2 wholes and 3 tenths as our final answer. Okay, at the bottom of page 72, you can go ahead and try the on your owns if you need some extra practice. There are 4 of them on the bottom. Okay, so the answers, number 1 is 2 and 1/7. Number 2 is 2 and 8/9. Number 3 is 5 and 1/2. Number 4 is 3 and 1/5. Next, we're taking a look at page 73 and example 3. Switch colors. All right, example 3 is going to be using the order of operations. So we have multiple things happening. So it says evaluate 5 and 1/4 divided by 1 and 1/8, subtract 2/3. So first we'll get it written out. We have 5 and 1/4 divided by 1 and 1/8, subtract 2/3. Now when we evaluate this expression, we have to decide whether we're going to divide first or subtract first. In PEMDAS, the division has to happen before subtraction. So we're going to really pretend this minus 2/3 is not there at this point, and we're going to focus on this first part of this expression. So we're going to look at 5 and 1/4 divided by 1 and 1/8 and start there. So now this is just like example 1 and 2, where we're going to change our mixed number into an improper fraction. So whole number times denominator, add numerator. 5 times 4 is 20. Adding the 1 is 21. So this becomes 21 over 4. Over here we have whole number times denominator, add numerator. 1 times 8 is 9, 1 times 8 is 8, plus 1 is 9. We have 9 over 8. Now we go ahead and see if there's anything we can simplify. Well, 4, the only factors of 4 are 2. Oh, excuse me, I forgot to flip the fraction. So, first thing we'll do is keep 21/4 the same. Change our sign. I almost forgot about this part. And we'll flip our fraction to the reciprocal. Now we can do our simplifying. 4 can go into 4 1 time, and 4 can go into 8 2 times. Now 9 cannot go into 21. However, there is a number that can go into 9 and 21 evenly, and that's 3. 3 can go into 9 3 times, and 3 can go into 21 7 times. So we can reduce those still. However, it's not going to be using a 9. It'll be using a 3. Now we can multiply. 7 times 2 is 14. 1 times 3 is 3. Let's see if we can take some wholes out of there. 3 can go into 14, and it can go into 14 4 times. So we're going to make a big 4. 4 times 3 is 12. So we have 2 leftovers from 12 to 14. So those leftovers go on the top, and the 3 stays the same. So our final answer is 4 and 2/3. Now if we look up here, we have one more step to do. We have to subtract 2/3. So if I look back down in my problem, 14/3 and 4 and 2/3 mean the same thing. If I need to subtract 2/3, I probably want to go back to my improper fraction and use that version in order to subtract 2/3. So what we can do here is take 14/3, which is the answer we got before we took our wholes out, and we could subtract 2/3. Notice how the bottom denominators are already the same, so we don't actually have to do anything besides subtract the numerators. 14 take away 2 would get us 12, and we keep our denominator the same. Now we can figure out how many holes go into 12, and there are 4 holes, and it comes out nice and evenly. So this is our first answer to the first step. 4 would be our final answer to the very final step. So if I were to answer an answer in the box, it would be a whole number of 4 after the whole expression is solved. Okay, lastly, there is a real-life application question, which is example number 4. So we'll take a look at that one next. Example 4. It says, 1 serving of tortilla soup is 1 2/3 cups. A restaurant cook makes 50 cups of soup. Is there enough to serve 35 people? And explain. So we are making tortilla soup. We'll write that out. And it tells us that 1 2/3 cups is going to be 1 serving. So if I order tortilla soup at this restaurant, 1 2/3 cups is how much I will be getting. It also tells us that there are 50 cups total that the cook is making. And we want to know, can we serve 35 people? So what we're going to do here is take our 50 cups total and divide by 1 2/3 per serving and see if we can get at least 35. So 50 cups would be 50 holes, which would be 50 over 1. I'm going to divide my 50 holes by 1 2/3. So what I can do here is keep 50 over 1, change the division sign, and I have to flip this fraction. However, I'm not going to flip it until I've got it into an improper. So we're going to take 1 times 3 and add the 2. So 1 times 3 is 3, add the 2 would be 5. So this turns into 5/3. So if I flip 5/3 around, I have 3 on the top and 5 on the bottom. So at this point, I can now simplify. 5 can go into 5 1 time. 5 can go into 50 10 times. So now I'll do 10 times 3, which equals 30. 1 times 1, which equals 1. So I have 30 servings that I can serve people. So is 30 going to be able to serve 35 people? We would say no, we cannot serve 35 people. We can only serve 30 people. At this point, go ahead and look at the bottom of page 73. You have 5, 6, 7, 8, and 9 for your on your owns. Go ahead and try those if you'd like some extra practice. Okay, if you tried them, number 5 is 8 1/8. Number 6 is 4 8/9. Number 7 is 2. Number 8 is 1/3. And number 9, the answer is yes. There are 18 servings of soup, so you can serve 15 people. That is the end of this lesson, so go ahead and stop the video and try the practice problems in class. And they start on 74 and continue on to 75.